Hello class. Today we're going to talk about classifying numbers. So by the end of this lesson, what we're going to learn is how to classify numbers by kind. Now why are we doing that? Well, the 8th grade standard says that we're going to extend previous knowledge of sets and subsets using a visual representation, which means pictures, to describe relationships between sets of real numbers. So the types of sets that we're really talking about are these. There are 6 number sets that the state of Texas says that you have to know: natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Now, for good measure, what I'm going to do is I'm going to throw in 2 more sets, complex and imaginary numbers, just so that you're familiar with them. So here is the visual representation that they were talking about. And if you'll notice on this particular image, you've got natural numbers. Well, natural numbers are the first set that we'll deal with, and we'll come back and talk about that in just a minute. And natural numbers are found within whole numbers. And then natural numbers and whole numbers are found within integers. And then natural numbers, whole numbers, and integers are found inside rational numbers. And then we have another set that's separate from those called irrational numbers. And then both of those, rational and irrational, are part of what we call the real numbers. So the purpose of this lesson today is to define each of those. So when we get to a definition, I'm going to read it through, and in order for you to write it down, you'll need to pause the video because I'm going to just kind of move on through so that this is not like what's in class, but just to giving you the information. Okay, here's another graphical representation of those same number sets. And this one, I like this one a little bit better because it kind of gives us an idea that everything's within a box. So we've got the natural numbers are found within the whole numbers, which are then found within the integers, which are then found within the rational numbers. And then you got these little sneaky devils that aren't part of that, called the irrational numbers, that are underneath this little shelf. And then you've got this big border that goes around it that tells us that all of those are part of the real number system. So every number that we deal with is going to be part of what we call the real number system. So here we go. Here's some definitions. Natural numbers. They're also called counting numbers. And these are the numbers that we use for counting. They're our finger numbers. That's all it is. They're just 1, 2, 3, 4, 5, and so on and so forth. Just nice, pretty little easy numbers. Then we move on to the next set called the whole numbers. And the whole numbers take all of those natural numbers, the ones that we just talked about, and it adds one number. It adds the number 0 to it. And that's all it amounts to. Okay, so basically what that amounts to is that we've got the right-hand side of our number line. Okay, let me write that a little differently. We've got the right-hand side of that number line. We're here at the beginning, we've got 0, then we got 1, 2, 3, and so on. Okay, just nice, pretty little numbers. But then you'll notice that half of that number line is missing. Well, that's when we bring in the integers. And integers are the whole numbers and their opposites. So this part over here on the right-hand side of that number line, those are called our whole numbers. The 1, 2, 3, 4. Well, when we have both sides of that number line, we call those whole numbers the positive integers. They're all the positive numbers that we've got. Okay? And then now, because of whole numbers, we've got that 0 there in the middle. Okay, so that divides up the positives and the negatives. And then now we've got this whole left-hand side of the number line going this direction, and those are our negative numbers. Now, that doesn't necessarily mean that just the negative numbers are integers. That whole number line right there down at the bottom, this whole number line right here, they're all called integers. Even these numbers with positive signs on them, they're integers. They're just also called whole numbers, okay? So we need to understand this idea of opposites. Opposites means, okay, the distance away from 0, just on the other side of 0. So if I ask you, like the example that we have here, what is the opposite of positive 3? Well, you're going to say negative 3 because they are the same distance away from 0, just on the other side. That's what opposite means, okay? But I could also ask you the same thing. What's the opposite of negative 3? Positive 3, because it's the same distance from 0. So opposite doesn't mean the negative number. It just means whatever it is, I want the other sign. So if it was positive, the opposite is negative. If it was negative, the opposite is positive. And that's what I need you to understand about opposites. Okay, the next set of numbers, and this is the biggest set that we deal with, rational numbers. A rational number is any number that can be expressed or written as the quotient or fraction a over b of 2 integers, with the denominator b not equal to 0. So really what's important in this particular problem is a rational number is any number that can be expressed as a fraction. That's what I need you to remember about rational numbers. So any number that I can write as a fraction, that's going to be a rational number. Okay, now real quick, let me pull up a calculator real fast to kind of give you some examples of some things. Okay, so if you were to look at this calculator, my thing's not working right there. If you were to look at this calculator, to identify a rational number, if I were to type in 1 divided by 2, you'll notice it is a fraction. So when I hit that enter, I get a nice pretty little decimal, 0.5. That tells me that's a rational number. Okay, I could also hit something like, oh, I don't know, what about 1 divided by 6? Now that is also a rational number because 1, if you'll notice, I created it by using a fraction. So that means it's got to be a rational number. But you'll notice on the end of this, it's got 0.166666667. So any repeating decimal is going to be a rational number because I can create it with a fraction. But in this particular one, you'll notice there's a 7 on the end of it. This is what we call a calculator rounding error. Okay, basically what it amounts to is that calculator, it worked all that out, 9, 10 digits long, and it wanted to stop. It got tired. So it looks at the next digit right off the screen, determines what it is, and then rounds accordingly. In this particular one, there's going to be a 6 on the end of that. So that our rounding rules when we have a 6 is to bump the next one up 1. So that's why that 7 is there. So we have to be smart enough to know when a digit is really repeating. So that 0.1666666, even though there's a 7 at the end, that 6 keeps going. So we would end up writing that number as 0.16 with a bar on the 6 because that 6 repeats. Now, there are some others that are really kind of interesting. If I were to do, let's say 1 divided by 11, 0.09090909, that's another example of a rational number. Okay? There's a pattern of repetition. So a rational number is any number that I can write as a fraction. So when we type it into the calculator, there's going to be a pattern of repetition. And that's what I need you to remember about rational numbers. So now let's look at this next set. The next set's called an irrational number. Okay, so irrational numbers is a real number that cannot be written as a simple fraction. So that's the part I need you to really understand. The decimal goes on forever without repeating. One of the most famous irrational numbers we have is pi. And I wrote that one kind of bad. Let me rewrite that real quick. It's a little bit better. That pi digit. So if you were to actually, and on your calculator, there is a pi symbol, and we'll look at that in class. But if I were to press my second button in this little exponent key, I get a pi symbol. And if I hit enter, you'll notice that it gives me a number that goes all the way across the screen there, 10 digits long, 9, 10 digits long, but there's no pattern of repetition. 3.141592654. Can you predict what that next number is going to be? No, you can't. Now, if you look at my calculator, that 0.0909090909, can you predict what that next number is going to be? Yes, we know it's going to be a 0 and then another 9 and so on and so forth. So I can make a prediction. Another number that is an irrational number that we need to know of, which is very famous, is called the square root of 2. If I were to type in second x squared to get that little square root and press the 2, hit enter, you end up with that right there, 0.1414213562. I think I said 0.1, it's 1.4. Okay, but you'll notice right there that I can't make a prediction as to what that next number is going to be. Thus, that's an irrational number. The last one I want to talk about is square root of 3. These are the 3 most famous irrational numbers that we have. Okay, so square root 3, enter, and you get that one, 1.7320500808. Now, you might think that continues 0808, but it doesn't. Okay, it does change there in that particular thing. So those are 3 irrational numbers, and you can now identify what they look like on the calculator. If there is a pattern of repetition, it's rational. If there is no pattern of repetition, it is irrational. And we need to remember, irrational means a number that cannot be written as a simple fraction, whereas in rational, it's a number that can be written as a fraction. All right? Last number set that you're going to be tested on, the real number set. Real numbers. Okay, now real numbers are any number that can be placed on a number line, and that's the part I need you to write down. Okay, so any number that can be placed on a number line. That number could be positive or negative. It could be large or small. It could be a whole number, or it may have decimals in it. They're all real numbers. And the reason why they're called real numbers is because they're not imaginary numbers, which will be the next thing that we talk about. Now, real numbers is as far as you're going to be tested on. So that's as far as I'm going to go, as far as having you write down the definitions. Now, just to kind of be aware of what's going on, there are a couple other definitions I want you to think about. There is a set of imaginary numbers. Imaginary numbers is a number that can be, when squared, gives a negative result. Okay, so to kind of give you an example, I'm going to do some math here that is a little over your head, but that's okay. If I were to take the square root of -1 and I were to square that, I'm going to get -1 as an answer. The only problem is you cannot square root a negative number. It will give you an error message. Okay, so that tells us that anytime you have the square root of -1, that's going to be equivalent to I, which is your first imaginary number. And then lastly, we have what we call complex numbers. Complex numbers is any combination of a real number and an imaginary number. So we get like 1 plus I, or 2 minus 6I, or negative 5.2I plus 4. Any real number plus an imaginary number makes a complex number. Now these last two, I just wanted you to be familiar with them. You don't have to know them, but when you get into Algebra 2 and they start talking about these, I want you to remember, oh yeah, we did talk about that in Mr. Nash's class. I don't remember what he said, but I remember the name. And that's what I need you to think about, okay? So now, thinking about those, your homework assignment is going to be something very similar to this right here. I'm going to give you a list of numbers, and I want you to tell me what number sets they belong to. So if I gave you this number 5 right here, where would I put that number 5? Where could I put it? Would it be a natural number? Yes, because natural numbers are counting numbers. They're on your fingers. So we could put a 5 in the natural numbers. What about a whole number? Yes, the 5 is a whole number. What about an integer? Yes, the 5 is an integer. Now my pen's not going to show up with this rational, but is the 5 a rational number? Yes, I can write that as a fraction. Oh, it did show up. Now, if it is all of those, it's also going to be a real number. Every number we talk about is going to be a real number. So what if I gave you that -12? I gave you the -12. Is the -12 a natural number? No, because it's got a negative. Is it a whole number? No, because it's got a negative. Okay, what about -12? Is it an integer? Yes, it is. So that's the first place it would go. If it's an integer, is it rational? Yes. And if it's rational, is it real? Yes. Okay. Now what about 6.4 right here? What's that going to be? Well, would 6.4 be natural? No. Would it be a whole? No. Would it be an integer? No. Even if I put a negative on that one as 6.4, it's not going to be an integer. Okay, just because it's got a negative doesn't make it an integer. But I can write this one as a fraction, so 6.4 starts out as rational, and then it would also be real. Okay, now what about that pi button? What about that pi symbol? Well, would it be natural? No. Whole? No. Integer? No. Rational? No. Because we know pi is irrational. Now, if it's irrational, is it also real? Yes. Okay, and that's what you're going to be doing on your assignment. So this is what your assignment looks like. I'm going to give you a series of numbers, and I want you to identify what sets they belong to. Okay, now we're going to do them. You could do them with these abbreviations, but on your paper it doesn't have the abbreviations. Okay, or you can do it right here with just using the abbreviations for each set. So let's go through. Let's start with number 2 instead, and we'll come back to number 1. Okay, so let's look at number 2 with 11. Is 11 a natural number? Yes. So you could just put an N for natural. Is 11 a whole number? Yes. So you could put a W for a whole number. Is it an integer? Yes. So we would put INT for integer. Okay. And then if it's all of those, then we know it's also going to be rational. So we'll put rat for rational. And if it's rational, we know it's also going to be real. Okay. So now let's come back to the -15. -15, would it be a natural number? No. Would it be a whole number? No. Is it an integer? Yes. So we would start by writing integer. And then if it's an integer, I know it's going to be rational, and I know it's going to be real. Okay. Now, something like number 3, you're going to have to type that into the calculator. Okay, so if I were to get my calculator back out, type that one in, square root of 30, so second, square root 30, hit enter. We know it goes all the way across the calculator. Is there a pattern of repetition? No pattern of repetition. So that means this is irrational and real. Okay? And so that's what you're doing, just like that. So if there are any questions, shoot me an email, and I'll talk to you later.